TSAI Think Tinker Learn. Today, we're launching into a critical session of a System Design Essential series. We're breaking down API mechanics, specifically the exploded views of versioning and pagination. This is a concept-first introduction to help you build your system design foundation quickly. As with the rest of the series, we keep these videos high level to respect your time. So if you want a deep dive into a specific, let's say database index strategy or HETIOS implementation, let us know in the comments. Before we tear this engine apart, please hit that like button, share this video, and subscribe. You can find a full detailed technical article over on our companion site, which is up here. The link will be in the description. It's a GitHub pages. It will have several articles. This is a work in progress. As and when the articles are available, they will be hyperlinked there. Okay, let's get started. Now, why do we use version? API versioning isn't about the file organization. It is a rigid social contract between client and server. To an internal developer, changing username to, or let me put it this way, user underscore name to username seems like a trivial cleanup. But externally, this is a silent break. It detonates mobile apps and third-party dashboards with null pointer exceptions without a single error code to help the user diagnose the problem. The takeaway is simple. When you break the contract thoughtlessly, you break your user's trust. Our first exploded view is URI path routing. While REST purists argue a resource shouldn't change its URL just because its format changed, pragmatism usually wins in the industry. By putting slash v1 slash or slash v2 directly in the path, routing can live in a centralized gateway like Nginx or Kong. This allows for a clean, entirely separate deployment environments and provides distinct cache keys for CDNs natively, making it the industry default for discoverability. Our second view is header and content negotiation. This keeps URL as pure, stable resource identifiers while handling versioning via metadata like an accept version header. While this has a high structural purity, it sacrifices browser discoverability. But here is a critical failure point. If you don't use a very header, a CDN might cache v1 data and fatally serve it to a v2 client because the URL looks identical to the cache. This approach requires complex client setup to work safely. Versioning without a lifecycle is like having an emergency exit with no evacuation plan. A responsible API maintains parallel versions in a sunset window or 6 to 12 months. We use programmatic notice, sending deprecation and sunset headers to warn client applications of the impending deadline automatically. This gives developers time to migrate before a sudden 410 gone or 404 not found is thrown, preventing system shock. Now, let's talk about the infinite feed and why we paginate. The broken state is the simple select star. Returning an unconstrained payload against millions of rows will instantly crash your database memory, paralyze your network gateways with massive response times, and collapse the client application by consuming all available RAM. The architectural fix is to deliver data in digestible, predictable, algorithmic chunks. Offset pagination is the most common starting point. Syntactically, we see this in UIs as page 3. Under the hood, it relies on a simple SQL translation, limit 5, offset 10. The database engine literally counts rows linearly from absolute beginning until hits the defined offset coordinate. This is perfectly fine for internal admin dashboards or static data catalogs where the underlying row remains stable. The failure point of offset is the drifting floor bug. Offsets are strictly positional. In high velocity feeds, if a user is reading item 1 through item 5 and a new item 0 is inserted at the top, all underlying positions physically shift. When the user requests the next offset, they see duplicated data. Item 5 appears again because now it is at position 6. On the flip side, deletion causes items to be skipped entirely. This is a silent but frustrating bug for users. Cursor-based pagination solves this by saying, give me next 10 items strictly after this specific identity entity identifier. The cursor acts as a physical anchor tied to an ID, not a mathematical row position. It is completely immune to new data being inserted or deleted above it. Usually encoded as an opaque base64 string containing an ID and a timestamp. This allows you to change server logic without breaking the client contract. It is the gold standard for social media infinite scrolls. When we look at the pagination at scale, we see the B-tree advantage. An offset query for 500,000 page must discard 10 million rows via a linear scan. Keysert pagination, however, uses index scannable conditions like where price greater than X. This allows the database to drop straight down to B-tree to the exact anchor in O log n microseconds. Remember, your API limits are ultimately dictated by underlying database data structures. A great API should be self-describing, a concept known as HATIOS. In the response envelope, the server shouldn't just send data. It should embed the exact pre-formatted URL for the next page. This makes the client application a dumb terminal. It doesn't need to manually construct cursors or calculate math. It simply follows the provided link, which allows the server to change its pagination strategy behind the scenes without needing a client-side code update. Let's look at two under-the-hood tricks. First is the plus one trick. Fetch one extra row from the database. For example, ask for 21 when the user wants 20. If 21 rows return, you cheaply determine that the has next is true without a separate count query. Second is system boundary defense. Always cap the limit parameter. Without a hard maximum, a single malicious or a buggy client can trigger a massive database scan and exhaust your server resources. Here is the synthesis matrix. Offsets are best for stable, static data and internal tools. Page numbers are best for UIs that require explicit jumping. Cursors are your choice for live, high velocity feeds and activity streams. And keysert pagination is the performance winner for high volume sorted queries where you can leverage binary indexes effectively. On the Seniors trade-off maps, notice the empty quadrant. Arbitrary page jumping on a high velocity live data is fundamentally intention. You cannot have both perfect random access and perfect real-time consistency. You must choose a trade-off. Either accept eventual consistency where user might see duplicates or restrict the UI to forward only navigation using cursors. To wrap up our final architecture review, remember that APIs are social contracts. Deprecate with empathy. Infrastructure dictate design. Favor cursors over offset or scale because of binary trees. And finally, lead with trade-offs. The best engineers don't just memorize patterns, they map constraints. So for your current project, are you team offset or team cursor? Let me know why in the comment. Don't forget to like, share and subscribe to CSAI Think Tinker Learn for more system design essential. See you in the next